All right, let's go through density. So we've talked about matter, and one of the physical properties that we talked about matter was density. And I love density. Density is just the greatest. I love it. So what is density? Oh, density is mass divided by, that's mass, not what I wrote. Mass divided by volume. So mass divided by volume, that is density. Great. So if you're looking around, what's something that we typically come in contact with all the time? And that is water. So water is amazing. And you know what else is amazing? The metric system, or the SI system. The metric system has made water to be 1 gram per 1 milliliter. So if I had 1 milliliter of water, you could say that that is 1 gram of water. That is volume, that is mass. Cool, so the density is always mass divided by volume. And you're typically gonna see it in the units grams per milliliter or grams per centimeter cubed. And you know what else is amazing about the metric system? Is 1 milliliter is equal to 1 centimeter cubed. So if you take 1 centimeter by 1 centimeter and make a cube, that is equal, so 1 centimeter by 1 centimeter by 1 centimeter by 1 centimeter, that is equal to 1 milliliter. Yes, metric system. Yes. Metric. So let's think. Have you ever put something in water or been in water or seen things float or sink? I hope so. What does it have to do with density? So the idea is anything less than 1 gram per milliliter will float, and anything greater than 1 gram per milliliter will sink. So let's play a little game. Will it float or will it sink? Here we go. So will it float or will it sink? So in taking a look at this, I have this big container here. It's a big beaker, large glass container of water. Will it sink? Will it float? I have tongs. Will it sink? Will it float? It doesn't float. So we must say that it is greater than 1 milliliter, gram per milliliter. What about this rubber cap, this rubber stopper? Will it sink or will it float? It sinks. So what's true about its density? You got it. I have a cork stopper made from cork. Cork is made from the cork oak tree, just in case you're curious. Will it sink or will it float? Oh, it floats. So it must be less than 1 gram per milliliter. So if I wanted to start putting these in order, I could. There. I have some plastic tongs. Will these float or sink? It floats. Great. So I noticed that these two things are less dense than water. These two things are more dense than water. If I wanted to put them in order, exactly from least dense to most dense, I could take the mass of this on a scale and figure out the volume of this using displacement. And displacement basically is use a graduated cylinder, you record the volume, you put that in there, and how far that moves up, that is the amount of volume of your particular item. Then we can figure out mass divided by volume gives you density. One more thing. Will it sink or will it float? This is a bowling ball. It's actually Jim B bowling ball. So, made in Sweden, just like me. Will it sink or will it float? Sink or float? It's a bowling ball. Oh, it sinks. It's a bowling ball. But what can we tell you about, I know it looks like it's floating a little bit, but that's just the glass. What's the density of this bowling ball? Yes, you're right. Greater than 1 gram per centimeter cubed, or greater than 1 gram per milliliter. Let's see what I can do. I'm gonna work a little chem magic here. Take my bowling ball, I'll be right back. Whoa! Now I've added a nice layer onto Gym B. I wanna see if our new Gym B will sink or float. Sink or float? Oh, Gym B! The bowling ball is floating. What must be true of its density? Yes, you're correct. Less than 1 gram per centimeter cubed, or less than 1 gram per milliliter. Wild. All right, I've got to confess. This is actually a different bowling ball. It's a different bowling ball. This one is less dense than water. This one's more dense than water. Hey, great. So let's keep talking about density, because we love density. And let's make this thing a little more chemistry on us. So let's talk about some calculations using density. Here's a question. Let's write our own question. So if I had a block with a mass of 50.0 grams and volume of, let's do 12.80 milliliters, what's the density? So what's the density? Remember, we love density. It's mass divided by volume. So in looking at this, I'm just going to put the mass over the volume, and it is going to be density equals 50.0 grams divided by 12.80 milliliters. And remember, if it said centimeters cubed, that's the exact same thing as a milliliter in regards to volume. What a beautiful metric system it is. So 50 grams divided by 12.8, that is going to give you 3.90625. And then I don't want to forget my units here. Grams per milliliter. I know you're sitting there, you're looking and yelling at me. Sig figs! You're right. I would not have that many significant figures there. So if you look to this, I have 1, 2, 3 sig figs, 1, 2, 3, 4 sig figs. My answers are going to have 3. Round this to be 3.91 grams per milliliter. Excellent. Hey, let's do another example. So something similar to that. I'm going to give you the density this time. So the density, and sometimes density is written like this. It's kind of like a row. Density of a material is 0.386 grams per centimeter cubed. You're like, that would float, that would float. You're right. The mass is 101 grams. What is the volume? So let's figure that out. So I have how much I love density. So density is that weird letter like that, or density is equal to mass divided by volume. So I have density 0.386 grams per every 1 centimeter cubed is equal to 101 grams for x centimeters. So I'm just going to say x. So you can solve this multiple ways. I'm going to multiply both sides by x, get 0.386 grams per centimeter times x equals 101 grams. Then I'm going to divide both sides by this number, 0.386 grams per centimeter cube, 0.386 grams per centimeter cube. X is going to be equal to some amount of centimeters cubed. My grams get canceled out and centimeters are left over, or volume centimeters cubed. So it is 101 divided by 0.386. I end up getting a number 261.6580311. No, please don't write that. Sig figs. Remember, multiplication division, we have three significant figures on both sides. I'm going to say, and round it to three significant figures, 262 centimeters cubed. Excellent. Great. I'm going to put another example in here for you guys. I want you guys to test it and see how you do. And that is density. Love density. And I got two more questions for you. So, object A has a mass of 500 grams and a density of 5.0 grams per centimeter cubed. Object B has a mass of 650 grams and a density of 6.5 grams per centimeter cubed. Question is, let's get rid of that one. No, let's not. In looking at this, which object would displace the most liquid? In other words, if I put these in water, both of them would sink. See, that's the density there. That's the density there. Both of them would sink, but which one would displace the most liquid? In other words, if I put them into a giant beaker and there was water, and I put the material there, which one's going to make the water go up higher? And then explain why. Great. I'm looking forward to hearing your guys' responses, and we'll go over that tomorrow in class. All right? Let me know if you have any questions.